So the idea of panspermia is that life can travel through space naturally, like seeds being spread around the universe. It's been debated for ages, but we didn't have any proof until recently. Now, with new discoveries and research, we're taking it seriously. People used to think it was impossible for living things to survive being launched off one planet, traveling through space, and land on another planet. But turns out microorganisms can handle it. Scientists got interested in this again in the 70s when they found rocks from Mars here on Earth that proved it's possible for rocks to travel between planets in our solar system. They figured out some ways that materials can be sent into space and survive the trip. So yeah, panspermia might be a real thing after all. Basically, scientists were wondering if living things could have hitched a ride between planets in our solar system. But for that to happen, microorganisms would need to survive being launched off of one planet, flying through space, and then landing on another planet. So, scientists have done a bunch of experiments trying to simulate all those crazy conditions. They found that spores can survive each stress individually, and even combined stresses can be simulated in the lab. For instance, microbes could totally survive the trip from Mars to Earth or any other habitable planet in our solar system. And get this, it's not just Mars and Earth that could be swapping germs. There are all these cool moons around Jupiter and Saturn that might be habitable too, like Io, Europa, Ganymede, Callisto, Titan, and Enceladus. Plus, microbes can survive in space for years with just a little UV protection, like they could be space superheroes with a dash of sunscreen. And if they're shielded by 6.5 feet of meteorite, they could live for 25 million years up there. That's longer than most marriages last. But wait, it gets crazier. Scientists found microbes on Earth that were brought back to life after 250 million years. That's like finding a fossil and then it jumps up and says, "Surprise!" All these discoveries have changed the game when it comes to finding life on other planets. We used to think life could only exist on cushy Earth-like planets. But now we know that extreme environments are fair game. And with our improved knowledge of these environments, we've been able to develop astrobiology, which is all about studying the origin, evolution, and distribution of life in the universe. Mars is one of the most promising places to look for life. We've found evidence that it used to have an environment similar to Earth, which means life could have flourished there. And get this, scientists found trace amounts of methane in the Martian atmosphere that could be produced by living organisms. Plus, they recently discovered subsurface liquid water lakes on Mars. So, maybe there are some Martian microbes chilling down there. Europa is another exciting prospect. It has a subsurface ocean that could support life similar to Earth's deep ocean hydrothermal vents or the Antarctic lake Vostok. And Enceladus has hydrothermal vents on its subsea floor and high-speed jets of water vapor and organic-rich particles gushing out from its southern region. So who knows what kind of alien creatures are lurking out there? Bottom line, space is wild and full of surprises. Who knows what kind of crazy stuff we'll find next? Yeah, that long explanation was all about panspermia. But that's definitely not the only theory about the origins of life in space. There's just panspermia theory, but there's also directed panspermia. This theory is a bit crazy though. It suggests that life on Earth was deliberately seeded by an advanced extraterrestrial civilization. This idea is based on the assumption that life is rare in the universe and that it's unlikely to have originated on its own on Earth. Directed panspermia is basically the idea that dudes from other planets intentionally sent life to Earth. I'm not kidding you. Some people think that extraterrestrial beings might have purposely sent microorganisms or even whole organisms to our planet to kickstart life here. The idea is that those dudes might have wanted to spread life throughout the universe, and Earth was just one of their stops. It's kind of like intergalactic gardening. They planted the seeds of life and let it grow. Now, this theory might sound a little out there, but some scientists actually take it seriously. They argue that it's possible that life on Earth is too complex to have just randomly formed on its own, and that an outside force had to have played a role. I personally prefer classic panspermia theory over this one. There's another theory called chemical evolution, and it suggests that life on Earth originated from simple organic molecules that formed spontaneously in the early Earth's atmosphere or in space. These molecules then combined and evolved into more complex structures, eventually leading to the formation of living organisms. The conditions on early Earth were different from what we see today. The atmosphere was mostly composed of gases like methane, ammonia, and carbon dioxide, and there was no oxygen. These conditions were conducive to the formation of organic molecules. One of the most famous experiments that supported the chemical evolution theory was the Miller-Urey experiment in 1952. In this experiment, Stanley Miller and Harold Urey simulated the early Earth's atmosphere in a laboratory and produced amino acids, which are the building blocks of proteins. This experiment demonstrated that organic molecules could be formed from simple inorganic compounds under conditions similar to those found on early Earth. Over time, these simple organic molecules combined and evolved into more complex structures, eventually leading to the formation of living organisms. This process is believed to have taken millions of years and involved many intermediate steps. While chemical evolution is still a theory, and there are still many questions to be answered about the origins of life, it provides a plausible explanation for how life could have arisen from non-living matter. Hey, ready for the next theory? Meet hydrothermal vent theory. This one suggests that life on Earth originated near hydrothermal vents on the ocean floor. These vents provide a unique environment where chemicals and minerals mix with hot water, creating conditions that could have supported the formation of organic molecules and the evolution of life. This theory is another idea about how life could have started on Earth. Basically, it suggests that deep under the ocean, there are these hot vents where water, heated by the Earth's core, comes out. These vents are full of minerals and chemicals that could have provided the perfect conditions for life to begin. Scientists think that the first living organisms could have started around these vents, using chemicals and minerals to create energy. Over time, these organisms evolved and spread out into other parts of the ocean. The hydrothermal vent theory is still being studied and debated, but it's an exciting idea that could help us understand how life began on our planet. The last, but not the least, RNA world hypothesis. This theory suggests that RNA, aka ribonucleic acid, was the first self-replicating molecule that led to the evolution of life on Earth. RNA is capable of both storing genetic information and catalyzing chemical reactions, making it a possible precursor to DNA and proteins. Basically, the name of this hypothesis is a fancy way of saying that life on Earth might have started with a molecule called RNA. RNA is like a cousin to DNA, which is what makes up our genes. Scientists think that RNA might have been the first molecule that could make copies of itself, which is a key part of how life works. The idea is that in the early days of Earth, there were all these chemicals and stuff floating around, and somehow these chemicals combined to make RNA. Then, because RNA could make copies of itself, it started to spread and evolve into more complex forms of life. It's still just a theory, but it's a pretty cool one. And who knows, maybe we'll find out one day that it's how we all got here.